Hey guys, welcome back. Yesterday we had left off with this new thing called Polydoku, and we had some challenges with the Polydoku that we worked through together, and we kind of saw how this process worked. And we left off with this problem up here where we figured out that we could work the Polydoku backwards. In other words, we can kind of start with this cubic function that goes down here and work our way back to this expression that we have up here, this 3x squared minus 4x plus 2, which we use to kind of fill in this blank. All right. Now the reason is, what the goal of today's lesson is to figure out why we would want to be able to do that and what usefulness this has for us. Okay. So to understand that, we're going to be talking about something called multiplication format and division format. So I'm going to kind of explain that right here. All right. So for instance, let's take a look at this expression. I have x plus 1 times this x squared plus 2x plus 3. And if I were to set up a Polydoku and multiply those two things, I would get this over here, this x cubed plus 3x squared plus 5x plus 3. All right. Now, using a very simple algebraic principle, the principle that whatever I do on one side of an equation, I must do on the other side of an equation, right? And what I'm going to do on the left-hand side here is I'm going to take this left-hand side and I'm going to divide it by x plus 1, which means over here, I must also divide by x plus 1. And then we look at what happens on the left side when I do that. The x plus 1s, they cancel out, and all that's left is this x squared plus 2x plus 3. And then on the right-hand side, we're left with x cubed plus 3x squared plus 5x plus 3. So this becomes our division format, right? So whereas we're going to start like this. We're going to say x cubed plus 3x squared plus 5x plus 3 divided by x plus 1 equals x squared plus 2x plus 3. So we know that we can multiply these two things, and because we can multiply those two things, we can say these two things divided equals this thing right here. And we can actually use Polydoku to do a division problem. All right, so think about this one, right? In 816, I have this cubic being divided by 2x plus 5. And remember, what's going to happen is there's going to be some expression that's left over here, and we don't know what that expression is. All right, so I'm going to set up a Polydoku to figure it out. I'm going to set up a 2x3 box, which I'm drawing horribly because I'm still not fully used to this pen. That's okay. All right, so there's my 2x3 box, and I'm going to put this 2x plus 5 over here on the side. And this cubic part, the 6x cubed plus 7x squared minus 16x plus 10, that's this piece right here, and this would actually end up on the bottom, right? This is what the diagonals would add up to. So I'm going to put that down here. I'm going to say 6x cubed plus 7x squared minus 16x plus 10. I'm going to put that down here at the bottom, and we need to figure out what goes up here at the top. Okay, so I'm going to grab a different color pen here so we can kind of differentiate things easily. All right, and here we go. So I'm going to start the Polydoku just like I did with this one up here. It's no different of a problem. I'm going to take that 6x to the third, and I'm going to put it right there. Okay, and because we know that the diagonals, right, there's not going to be any other term that combines with the 6x cubed. That first term was always by itself. And so we know that 6x cubed goes in that upper left-hand box, right? So then I know I need 2x times something to get 6x squared. So I know I'm going to need a 3 because 3 times 2 gives me 6. And I know I'm going to need an x squared because x squared times x gets me x cubed. Then I'm going to multiply down, right? So 3x squared times 5 is 15x squared. Right? And then I'm going to move over to the next column. Now remember, right, 7x squared is what we have to add up to. So when I look at this diagonal, let me grab my highlighter here. When I look at this diagonal right here, that's where my x squareds are going to end up. And I know that those two boxes have to add to give me 7x squared. Okay. So if I have 15x squared here, right, then I know I'm going to need a negative 8x keep selecting the wrong thing here. It wants me to have a highlighter. There we go. Then I know I need a negative 8x to go in this box, so that way when they add, I get this 7x squared down here. Okay, so I've got 2x times something gives me negative 8x. Well, I know I need a negative 4, because negative 4 times 2 gives me negative 8. And, oh, that should be a squared. And then I know I need another x because x times x gives me x squared. All right, and then I multiply down with the 5. So negative 4x times 5 is negative 20x. There we go. And then I take a look at my next diagonal. So I'm going to highlight this diagonal. All right, this is where my x's go. Grab my pen again. And I know that I need negative 16x. I have a negative 20x, so I will need a positive 4x to go here. That way when I do 4x plus negative 20x, I get my negative 16x. So 2x times something gives me 4x. Well, that's got to be a 2. And then 2 times 5 gives me 10, which is perfect because those match up. That's exactly what we needed there. So by working that PolyDoku backwards, we figured out what piece goes here. So we do 3x squared minus 4x plus 2. So what we have is a new way to divide polynomials using this PolyDoku method. And this is actually going to be very handy later on when we want to take something that is cubic and we want to factor it. And I'll show that to you later on. But that's essentially what we're doing with PolyDoku is we are working that multiplication process backwards, and multiplication backwards is simply division. So we have found a pretty clever way to divide polynomials. All right. So I'm going to do these two problems here with you in the practice slot so you can see PolyDoku working both ways. And so what I'm going to do here is I'm going to set up a box. And notice that we are multiplying these things, okay? So I'm going to set up a box. And sometimes when you set up your box, you don't get it the right size or you don't give it enough columns or whatever, and that's okay. So this first term, this x plus 4, I'm going to put that over here on the side. So I'm going to be splitting this up 2 ways. And then notice with this one, it's got an x cubed, right? So I would have x cubed. That would create a column. And then I'm going to have negative 3x squared. So that would create its own column. And then I would have a 2x. There we go. And then I would need a 4. So 4 can have the rest of this over here. And then we would just go through and multiply each piece, right? So we have x times x cubed, which is x to the 4th. And then we'll have negative 3x to the 3rd. X times 2x is 2x squared. X times 4 is 4x. And then we work the bottom row. So 4 times x cubed is 4x cubed. And then 4 times negative 3x squared is negative 12x squared. 4 times 2x is 8x. And 4 times 4 is 16. And then the last step here is to go through and combine like terms. So I'll do that in a different color here. So we have our x to the 4th. That's all by itself. So there's my x to the 4th. And then we have our cubes, right? Remember, the cubes, the squareds, and the regular x's, they'll all line up on these diagonals, all right? So we have a positive 4 and a negative 3, so that's going to end up being plus 1x cubed. And then I add up my x squareds here, so negative 12x squared plus 2x squared is minus 10x squared. And then 8x plus 4x, right? That's going to be 12x. And then the 16 is all by itself. Okay. So when I multiply these two things, what I get is x to the 4th plus x to the 3rd minus 10x squared plus 12x plus 16. All right, so that's multiplication. Now we can do division, right? And remember, division is this process backwards. All right, so here we go. We're going to set this up. Let me grab my pink pen first. I like my pink pen. All right, so set this up. And I'm going to put my x plus 7 here and split this 2 ways. And then remember, this x to the 3rd 5x squared minus 16x minus 14 is actually going to go down here along the bottom, remember, because we're going backwards. All right, so we have x to the third plus 5x squared minus 16x minus 14. All right, so I'm going to create a column for the x cubed first here. So I'm going to say, here's my x cubed. And remember, the highest degree term is always going to be by itself, right? So in this case, we have an x cubed right here, okay? And that means I have to have an x squared here, right? Because x squared times x gives me x cubed. And then I would multiply down, so I have x squared times 7, so that is 7x squared. I'm going to create another column, right, for the x squareds. And I have 7x squared here. I need a grand total of 5x squared, so I know that this has to be a negative 2x squared. That way, when I add those up, I get my 5x squared. All right, so x times something gives me negative 2x squared, so it's got to be a negative 2x. Right? And then negative 2x times 7 is negative 14x. Right? And then I got to create another column. This time for my x's. Right? And then I go like this. I look at this diagonal here. I have a negative 14x. I need a grand total of negative 16x's. So I need another negative 2x's. So when I add those together, I get my negative 16x. Then x times something gives me negative 2x, so it's got to be negative 2. And then negative 2 times 7 is negative 14. Okay. And that actually ends it. That's where we stop, because notice the negative 14 here matches up with our negative 14 down here, so we are good to go. So we actually don't need that last column. So I'm going to erase it. And let me get my eraser, and I'll just get rid of this because I don't really need it anymore. All I needed was 3 boxes there. Okay. And there we go. So next thing I'm going to do is I'm just going to write out what the result of the division is. All right, so we can say x cubed plus 5x squared minus 16 divided by x plus 7 is this thing up here up top, this x squared minus 2x minus 2. That's the result of the division. All right, guys, that's where we're going to stop today. So you kind of see a usefulness out of the PolyDoku and where we're going with this. Like I said, we can use this for polynomial division, and later on we're actually going to use this as a mechanism to fully factor higher order polynomials such as third and fourth degree polynomials, just like we have with the quadratics. All right, and we'll see that in future lessons. All right, guys, that's it for today's lesson. Try the practice problems, and good luck. See you next time.